say I suspended 2 Newton, 30 degree, let's call it W1, that means weight 1, and that is 30 degree with respect to the positive x, suspended 2 Newton. Let's say I'm suspending 2 Newton 30 degree with respect to negative x. Now, my question is how can I accomplish the equilibrium? How much force I need to apply? Oh, there is no pulley over here. That's right. Okay, this is the pulley. So now, okay. Now they are not equilibrium because the acceleration they are accelerating in this direction is because there is no forces acting on this side. So my question is how much force should I suspend here and what direction, what should be direction, so that the system is equilibrium and this thing, well, how do we know the system is equilibrium? When this ring do not touch the center. When this ring do not touch the center, that will be equilibrium. How can we accomplish that goal? Let's draw the diagram. First thing is, in physics class, you always need to draw the diagram. So, the diagram of this force table. So this is the force. This is the circle. This is the circle. 360 degree circle. 0 degree. 180. 270 and 90. Okay. Now let's say a string. We have a string this way. That is string number 1. We call it weight 1, and that is 2 Newton. 30 degree with respect to x. With respect to x, this is a positive x. And things are positive and positive here, and things are negative and positive here. And the another one is 30 degree with respect to negative x. And that we can call it W2, and that's also 2 Newton. How much weight do we suspend here? Another string. Now it is accelerating that way, is because there is no force acting down. How much force you should act so that the system is in equilibrium? Equilibrium means the net force is 0. How much force should we act? Let's call it W3. Should we act on string 3 so that the whole system is in equilibrium? That the net force of everything is 0. Okay, so we're going to use Newton's second law to accomplish this simple. So let's do step 1. Step 1. Let's see how much force acting on the x direction and how much force acting on the y direction for string 1. So string 1 has 2 components, W1x and W1y. So we're going to write W1 cosine 30 degree is equal to W1 is 2 Newton cosine 30 degree and 2 Newton cosine 30 degree is 1.73 Newton. And this one, W2 or W1 sine 30 degree. This is 2 Newton sine 30 degree, and sine 30 degree is 0.5. 0.5 times 2 is 1 Newton. Now we're going to do string number 2. So W2 also has two components, W to X, W to Y. W to X is W to cosine 30 degree. W2 is also 2 Newton. So cosine 30 degree. This time it is a negative because the X, this is minus and plus. So it's going to be negative 1.73 Newton. Y, W2 sine 30 degree, we should be positive 2n sine 30 degree, we should be 1 Newton. Now we will use Newton law. Our goal is to accomplish the net force is 0. So the force acting on the x direction. Now we're going to add up the force acting on the x direction. So force on the x direction is W1x plus W2x. So W1x, we already have that, 1.73 Newton. W2x is negative 1.73 Newton. So force acting on the x direction is 0. And that does make sense. Force acting on the x direction, there is no force acting on the x direction. The forces acting on the y direction, there is actually no forces on this force table right here on this force table acting on the x direction. We have to keep that in mind. So now we're gonna calculate the force acting on the y direction, W1y plus W2y. W1y is 1 Newton plus W2y is 1 Newton. So it's 2 Newton. So how much force, how much weight do we have to add on the third string? We have to add 2 Newton because 0 Newton plus 2 Newton is 2 Newton. So we have to add 2 Newton. But how do we know the direction? We can find the direction pretty easily. So tangent theta is equal to opposite over adjacent. So Wy over Wx. So Wy is 2n and Wx is 0. So we're going to write theta is arctan 2n over 0. However, this is not defined. Under two scenario, arctan 2n over 0 is not defined when it is 90 degree and when it is negative 90 degree. We will not add it positive 90 degree for obvious reason because it is accelerating this way. We're going to add it negative 90 degree so that we can accomplish the equilibrium. So it is negative 90 degree. So we will not add another force. We will not add